Hello viewers, I am Kausalya. Today we are going to see the rest of this problem number 1 which comes under the category of steady state error. And the problem is for a unity feedback system, the open loop transfer function is given like this. Here we are going to calculate the steady state error when the input is R of s which is equal to 3 by s minus 2 by s square plus 1 by 3s cube. Now we are going to calculate the values of generalized error coefficients, and here the first generalized error coefficient is C naught, which is equal to limit s tends to 0 f of s. The formula for f of s is 1 by 1 plus g of s into h of s. Since it is a unity feedback system, the value of h of s is equal to 1 here. Now we are going to substitute the value of g of s here. Once you substitute the value, our next step is we have to take the LCM. So when you take LCM, this 1 gets multiplied with s square into s plus 1. So s square, the equation becomes like this, right? Now we are rearranging this expression. So this s square into s plus 1 occupies the numerator part, and here these terms remain in the denominator. So finally, when you multiply the terms, we are getting an equation like this. That is s square into s cube, s square into 1, s square. Similarly, s square into s cube, and s square into 1, s square, plus here 10 into s becomes 10s, plus 10 into 2 becomes 20. So this is our required f of s expression, and the thing is we need to find C naught. So C naught is given by limit s tends to 0 f of s, which is equal to, so this is our expression for f of s, right? So just write this equation, and the next step is we have to substitute the value of s as 0 in this expression. So when you substitute, we are getting the values like this, and finally the value of C naught is found to be 0 by 20, which is equal to 0. So finally, the value of C naught is found to be 0 here, right? The next thing is we are going to find C1, and C1 is given by the formula limit s tends to 0 d by ds of f of s. So here again substitute the value of f of s here, and we have to differentiate this term. So here both the numerator and denominator has s terms, right? So we need to use the formula u by v. So what is the formula for this differentiation? It is given by here v square. So v into du minus u into dv, right? So here v square, so this is your denominator part. So the denominator part gets squared here. The next one is v du. So this is your v. So write down the v into du. We have to differentiate this numerator part. So when you differentiate s cube, you will be having 3s square, and when you differentiate s square, you will be having 2s, right? Next, minus u into dv. What is the value of u? It is s cube plus s square. And you have to differentiate this v. When you differentiate this term, s cube becomes 3s square, and this s square becomes 2s, and this 10s becomes 10, right? So finally we have differentiated this expression like this. And the next thing is we have to substitute the value of s as 0 here. So when you substitute s as 0, observe carefully. Here you see 0 plus 0, finally this term reduces to 0. So 0 multiplied by anything is again 0, right? Similarly here when you substitute s as 0, this term reduces to 0, and again the 0 multiplied by this term becomes 0. So 0 divided by anything is finally again 0. So the value of C1 is also 0, right? Our next step is we need to find C2, and C2 is given by limit s tends to 0 d square by ds square of f of s. This is nothing but differentiation of this, that is double differentiation, d by ds into d by ds of f of s. So d by ds of f of s, we already have this expression in previously. So here just substitute this term. So when you substitute d by ds of f of s is like, this is your d by ds of f of s, this entire term, right? Now again we need to differentiate this term and equate s terms to 0. The first thing is initially I am going to multiply these terms and make the terms simple. So when you multiply, s cube into 3s square becomes 3s power 5 plus again 3s square into s square becomes 3s power 4 and 3s square into 10s becomes 10 3s are 30 and s square into s becomes s cube. So 30s cube plus 20 into 3s square becomes 60s square. Again here s cube into 2s becomes 2s power 4 plus again s square into 2s becomes 2s cube and again 10s into 2s becomes 20s square and again 20 into 20s becomes 40s, right? Minus again you need to multiply these two terms. So when you multiply, s cube into 3s square becomes 3s power 5 and again this s cube into 2s becomes 2s power 4, right, minus 2s power 4 and similarly it goes on. I hope you can do this by yourself, right? So after multiplying and I am applying this, bringing this negative sign inside the terms. So here the common terms cancel each other. So finally I am getting an expression as, so this is our final expression. That is I am having a numerator and a denominator. Now what is our next step? We have to again differentiate these terms, okay, by using the formula again u by v. So what is the formula? As we have seen previously, v into du minus u into dv. Okay, this is your formula. Now I am going to use this formula and we are going to differentiate this one. So here the denominator term has to be squared. So already here there is a square. When you square this term, this becomes power 4. So here this is power 4. And again v into du. So what is the value of v? So this is your v. So write v as such and you have to differentiate the u term. So when you differentiate this, s cube becomes 3s square, right? So 20 into 3s square becomes 60s square. Plus again this s square when you differentiate becomes 2s. So 70 into 2s becomes 140s. And again when you differentiate 40s, this becomes 40, right? Minus again u into dv. What is the value of u? So this is your value of u, right? So here just substitute the values and again we have to differentiate the v. So when you differentiate this expression, this s cube becomes 3s square and this s square becomes 2s, right, 2s and this 10s becomes 10 here. Now I am going to substitute the value of s tends to 0 here. So when you substitute the value of s as 0, so here you see this term has s, so this becomes 0, this becomes 0 and this becomes 0. So this entire term reduces to 0. So 0 multiplied by anything becomes 0. So this second term of this expression reduces to 0. So we can leave this. So when you consider this part, when you substitute s tends to 0, you see this becomes 0, 0, 0 and here I am having this 20 square. So 20 square into here, this term reduces to 0, this term reduces to 0 and I am having a 40 here. So here 20 into 40 and this term is 0. So minus 0 divided by, again when you substitute s as 0, these three terms reduces to 0 and I am having 20 to the power 4. So here 20 to the power 4. So when you solve this expression, finally I am having 40 divided by 20 into 20. So which is nothing but 1 by 10. So the value of C2 is nothing but 1 by 10. The next thing is, we are going to substitute it in the expression. So E of t is given by R of t into C0 plus R dot of t C1 plus R double dot of t C2 by 2 factorial. So here just substitute the values here. So the value of R of t, we had find out this is our R of t and C0 is 0. And again R dot of t is minus 2 plus t by 3 and again C1 is 0 and R double dot is 1 by 3. So and this C2 is given by, the value of C2 is 1 by 10 into again this 1 by 2 factorial I had written here separately, 1 by 2 factorial. So finally, when you solve this expression, we are having 1 by 60. So what is the formula for steady state error? It is given by limit t tends to infinity e of t. So again, limit t tends to infinity and the value of e of t is found to be. So this is your e of t. E of t is found to be 1 by 60. So just substitute the values here. So here you see t tends to infinity. There is no t term available here. If there is a t term, we have to substitute the value of t as infinity. But here we are having a constant. So we cannot substitute anything. So finally the value of steady state error is found to be 1 by 60. So here comes the end of our problem. Hope you people understand. Thank you.